Hello students, today we will discuss about preparing a structural model of a continuous beam, and we will also learn how to draw the bending moment and surface diagram for the continuous beam using StatPro. So watch the video till the end. This video lecture is prepared by Soumya Sahu, lecturer in civil engineering at SKDAV Government Polytechnic, Rourkela, and this video is prepared for 6th semester diploma civil engineering students. So students, this is the first window, and now we have to double click on the StatPro icon. After clicking on the icon, we can see the StatPro window being opened. Here we have to click on New Project. After clicking on New Project, we can see another window pops up. We have to select space and we have to select the length units. The length units will be in meter, and we have to also select the force units, and we will select the force unit as kilonewton. I will change the file name over here. I'm changing it to experiment number 2. Structural model of continuous beam, and I can also change the location where the file is to be saved, but this is saved in local disk C, so I'm not going to change its location. But if you want, you can change the location over here. Then I will click on next. Then I will select add beam and I will click on finish. Then another window opens with a grid being provided with 10 by 10 grid. So in the experiment number 2, the continuous beam that has been given to us, it has got a hinge support at the beginning of the beam, and at the end it has got a roller support, and at the midpoint it has got another hinge support, and the total span of the continuous beam is 6 meter. So first I will click on 0, 0. So a node is created here. Then the next support is given at a distance of 3 meters. So I will click on 3 again. So another node is being created at 3. Then I will move forward. At the end of this beam, there is a roller support. So I will click on 6 meter. Now I will close the snap node. I'm closing the snap node. So now you can see 3 nodes and two number of beams are being created over here. Now in the next step, I have to assign the material property and sectional property to this beam. So I will click on general, and I will click on define, and I will give the sectional property of the beam. The beam is, let us assume the beam is rectangular in section. So I will provide the depth, say 0.3 meter, and the width say 0.25 meter, and the material I am choosing it as concrete material. Then I will click on add. Then I will close this window. After this, you can see the material and sectional properties are being reflected on the properties pop-up window. I will click on use cursor to assign and click on assign. See, it is changing into assigning. So I will move the cursor near the beam and I will select it. See, the R1 means reference number 1. This sectional and material property are being assigned to the first span of the continuous beam. If I will click it on the second span of the continuous beam, then I can see that the properties are being assigned to the second span of the beam. I can also use assign to view and assign to selected beams. So after assigning the sectional and material property, I will provide support conditions. So I will click on support and I will create support. So at the beginning of the beam there is a hinge support. So I will create a pinned support over here. Then I will again create another support, that is a roller support. So I will again click on create. It is roller, so the release will be FX. So I will add it. So now I have to assign these supports. Hinge supports are provided. I am choosing use cursor to assign. Okay. So hinge support is provided at the beginning of the beam and at the midspan of the beam. So I have provided the hinge support at the beginning and at the midspan of the beam. Now I will provide the roller support at the end of the beam. So I have assigned it. Now after assigning support, what would I have to do? I have to give load conditions. So I will click on load and definition. I will click on load case details. Then I will click on add. Then loading type, first I will select it as dead. Then I will click on add. Then I will then I can see load case 1 is created under load case details. Now I will create another load case, that is load case 2, and I will change the loading type from dead to live. Then I will click on add. Then I will close this window and I will select load case 1 and I will click on add. So here I will first choose the self weight of the load. See here the direction of the self weight is given as y and the factor is -1. It is -1 because the self weight is acting downwards. That is why the factor is -1 and the direction is global y direction. So I will click on add and you can see self weight is being reflected under load case 1. You can also see a question mark just on the left hand side of the self weight. This question mark appears because this has not been assigned to the beam. Once it is assigned, the question mark will disappear. So let's assign it. I am selecting self weight. I am using cursor to assign. I will click on assign and then I will select the beam. So now self weight is being assigned. See, the question mark has vanished from load case 1. Then I will select load case 2. Then I will click on add. So in the question it is given to us that there is a point load acting from at a distance of 1 meter from the beginning of the continuous beam and the value of the point load is 50 kilonewton. So I will first assign this concentrated load. I will click on member load and I will select a concentrated force. So the point load or the concentrated load is 50 kilonewton and it is acting downwards. So I will write it as -50 kilonewton. And see, from the beginning of the beam up to the point load, the distance is given as D1. So our point load is acting at a distance of 1 meter from the beginning of the beam. So I will put the value 1 meter over here and I will click on add. Then I will select a uniform force because in the last 3 meter of the beam, in the last 3 meter span of the beam, uh, there is an UDL. So I have to show that UDL, and the value of the UDL given in the question as 20 kilonewton per meter. So I will put the value of the UDL as a minus 20 kilonewton per meter, minus because it is acting downwards, so the direction will be the global y direction, but and since it is acting downwards, minus is given before the value. So d1 is the distance between the starting or the beginning point of the beam to the point where the UDL has started. So in our case, the distance is distance d1 is 3 meter, and d2 is the distance between the starting point of the beam to the end of the UDL. So in this case, this distance d2 is 6 meter, and now I will add it, and I will close this window, and now I will assign these loads. I'm using cursor to assign. So see, the point load is being assigned on the continuous beam. It has been acting at a distance of 1 meter from the starting point of the beam. And now I will assign the UDL. I'm using cursor again to assign. So now I have assigned the UDL over the continuous beam. So now I have given the material and sectional properties. I have given the support conditions. I have given the loading conditions. Now in the next step, I will analyze the beam. So I will click on analyze/print. I will select no print. I will click on add. Then I will close this window. I will click on perform analysis, and I will assign it. It is being assigned. Then I will click on analyze, and I will click on run analysis. So now you can see the StudPro software has analyzed and designed the beam, and it is showing that there are 0 number of errors. That means we have designed the continuous beam properly, and I'm going to the post-processing mode. Here you can see the beam, and I will click on take picture, and I'm taking the picture over here. These are the reactions at the supports. So I'm taking a picture of the reactions as well. These are the forces diagram. So I'm taking the picture of forces diagram. These are the stress diagrams. So I'm taking picture of stress diagram as well. Now I will click on reports. Now I have to give some input. So I'm taking the details of beam section, material support, releases, basic load cases, combination load cases, and loading generators, loadings. I'm taking all these input values. I will click on this double arrow. Now I will also input the pictures that I have taken. And now I will click on OK. So my report is prepared. I will save the report. So for saving the report, I will click on export. And I'm saving it. Now my report is saved, and this experiment is completed. So thank you, students. If you have got any doubts, you can comment in the comment section below.